Now, there's a couple of different ways that you can do this problem, and there is, I guess, what I consider the easier way. Let me just show you that, not show you, confuse the issue to show, okay, I'll kind of show you what I think is the easier way to do this problem. You have 1 plus 4 over x, and then that's all over 1 minus 16 over x squared. Now, you notice you start out with the fraction. I guess if you want to think about it this way, there's order of operations, and when you're dealing with brackets, what do you always start out with? The outside bracket. You work in from outside, so you want to do the inside brackets first. And technically, this is a bracket, which bracket the whole problem. This is a bracket, and this is a bracket that bracket those individual ones. And what we want to do is work inside this bracket to combine that, because there's nothing to do inside these bracketed items. Now what you're doing is, to do it the easiest way is you look for the least common denominator, or the whatever you want, least common multiple of the denominators. Okay, so now, this is supposed to be a squared here. So if you look for the least common denominator, what is that of all those denominators? X squared. See, this is a denominator, that's an x, this is x squared. The least common is x squared. Now what you want to do is, above this fraction line, you want to multiply by x squared over 1, the least common denominator, and x squared by over 1 here. All right. Now I'm going to do several steps, and on the next problem, we're just going to go quicker and quicker on doing the steps. Now what you will do with this is you will distribute this and this across the corresponding element. So I'm going to go then 1 times x squared over 1 plus 4 over x times x squared over 1, right? That's the numerator distributed. The denominator distributed is 1 times x squared over 1 minus 16 over x squared times x squared over 1. That makes sense? Do you see that? Now, this is supposed to, yeah, okay. Now then, if I take this numerator, this one right here, this thing right here, notice that the 1 times x squared over 1 just gives me x squared over 1. Then it's plus, and this one gives me plus 4x over 1. It's a common denominator of 1, so this numerator becomes x squared plus 4x all over 1, right? Correct? Now if I do the denominator, this one right here becomes x squared over 1 minus, these cancel, 16 over 1. So I have x squared minus 16 over 1. Now, if you invert and multiply this, it becomes x squared plus 4 over x squared minus 16. Essentially, it's just that thing and that thing. And I'm going to do this a little bit quicker just to show you how you can kind of bypass steps and get this same thing. I think it makes sense to you. If I start out once again with 1 plus 4 over x, and then go 1 plus minus 1 minus 16 over x squared. Multiply the numerator by x squared, the denominator by x squared. Notice I've left the 1's off. Now then, if I distribute this across here, that first term becomes x squared, and the second one becomes 4x, right? Correct? It's over 1, but just neglect doing it. Now the denominator, when you distribute this across there, it's x squared minus 16. You see, that's where you get right to that point. You see that? Does that make sense? So that's what you can do, and you can get to there without doing all that other rigmarole. And the other way you have to do it, if you do it, you have to get the common denominator of the numerator with the common denominator of the denominator, and then invert and multiply, and that's even more complicated. But you see I'm skipping steps going from here to here. But it makes sense, don't it? Right? Does it make sense? Now, once you get to this point right here, now start factoring. What's the numerator? What do you do with the numerator? Is there a common factor? And x comes out, x plus 4, right? What's the denominator? A difference of squares? How does that factor?
X plus 4, x minus 1.
Okay. Now what do we do? Common factors in the numerator and denominator? What's the common factor?
X plus 4.
X plus 4. And so our answer is x over x minus 4. Right? And you can essentially do it in that many steps. If you kind of know that, you're doing that 1 is in the denominator and it's common and all that. Does that make sense? That's the way we're going to do the problems. So I'll do 4. 5 minus 25 over x plus 5. 1 minus 3 over x plus 5. What's the common denominator?
X plus 5.
X plus 5, right? So you multiply x plus 5, x plus 5. Now, that x plus 5 times this 5 is going to be what? 5 times x plus 5, isn't it? When I take that x plus 5 times 25 over x plus 5, what happens? Do the x plus 5's cancel? And I have what? Negative 25? Is that right? So that's the numerator. Now tell me the denominator. What am I going to have first? 1 times what? See that 1 right there? Times x plus 5, right? Then minus, that minus right there. And then what are we going to have? Just 3, right? Wouldn't it be? See, this x plus 5 and that x plus 5 in the denominator would cancel. Is that right, Whitney? Now, you can maybe say in the future I can speed that process up. I don't have to write that 1 down, right? But now what you're going to have to do is you're going to have to combine like terms. And if I had written this down a little bit better, I could stack this. And I was going to try stacking it. I have to distribute that 5, don't I? So that's 5x plus 25 and then minus 25. Then this one, the brackets don't mean anything. I could go x plus 5 minus 3 is what? Plus 2. So that denominator, this denominator is kind of about as simple as it could be. But what do I have to do with that numerator? Combine like terms. So does it go to 5x? Now what's my answer going to be? $5x in the numerator and x plus 2 in the denominator. Is that right? Okay. Now on number 8. What I want you to do with this problem is I want you to look at it before you start working the problem. And I want you to think about what you think the answer is going to be. Now when you start solving problems in the real world, what you will do is this, right? You will look at what it is and you will say, this is my expected outcome, right? This is what I expect to happen. Then you get in and you try to solve it, and then you get a solution. Then you do what? You compare your solution that you derived to your expectation. And what did they better do? They better match. And if they don't match, what are you going to do? You're going to go back and re-examine the problem, right? I mean, if you have $30,000 in your bank and you're going to put a deposit in, what do you think the end result is going to be? More than 30,000, less than 30,000? More than 30,000. Now, if you put it in and you balance your thing and you come up with $25,000 as a balance, what are you thinking? This figure isn't right, is it? You better go back and re-examine what you did. That's the way you should solve problems. You know, if you have $32,540 in the bank and you put in $25,460, what are you thinking you better be in the neighborhood of? $57,000, right? 32 and 25, right? Your answer better be someplace in 57,000, maybe 58, whatever. Now, if you get 47,000, what are you thinking? I did something wrong here. That's the way you should work problems. You should say, this is what I think is going to look like, and then do it. And then say, now is this reasonable? So look at this problem, think about what it is, think about what your outcomes are going to be, and then start doing the problem. So you've had time to think about it. I don't want to hear what you think. I just want to know, what are we doing first when we're muddling through it? Least common denominator, right? What is it? So we're going to do x minus 8, x minus 8. Now then, what do you think? In that numerator, what are you going to do? You're thinking this is a bracketed item, right? So that 5 right here, what are you going to have to put after it? In a bracket, x minus 8, right? Now when you're taking this one times this, what's going to happen? The x minus 8 goes out, and what do you got left? Plus 3. Now essentially the bottom should be what? Real similar to the top, right, in terms of general way you do it. You're going to do 2 times what? X minus 8. And then you're going to do what? Similar to what you did on the top. What did you do on the top?
Plus 1? Or is it minus?
This is a minus right here. Minus 1. Right? That's it's similar to what you did on the top, right? Because that x minus 8 cancels. So now, this is looking right, isn't it? It's kind of looking right. So now what do you have to do with that problem? Distribute it and then combine terms, right? So when you distribute it, what's this top one going to be?
5x minus 1.
That's right. Plus 3, isn't it? Is that right? Okay. How about that bottom one? It's going to be what? Now you got to combine terms, right? What's that numerator going to be? 5x, what? Minus 37, is that right? The denominator is going to be now you can't reduce that down much, can you? So that's your answer. Did it help to look at the problem and think about it before you started doing it? I think it does. At least that's the way I tried to do it. And that's the way you see types of problems and you kind of say, oh, okay, this type of problem should get me this kind of a thing. Now, if you notice this, 9 through 17, do they look like similar kind of a problem? Their denominators are what? All x and x squared, right? So those are all kind of the same type. So once we kind of know how to do one, we should have an expectation of all those others should come out, right? And I'm going to do 14, it's the harder one. So it has 1 plus 3 over x minus 18 over x squared all over 21 over x squared minus 4 over x minus 1. Okay. Now, what is the common denominator of every denominator?
Yes.
X squared, right? Now, what this says is that you're going to take this times this, right? When I take 1 times x squared, what do I get? When I take that 1 times that x squared right there, what do I get? X squared, don't I? When I take 3 over x times x squared, so I'm doing 3 over x times x squared, what am I going to get? 3x, right? When I take 18 over x squared times x squared, what do I get? The x squareds cancel, right? They're common. And I have a negative 18. See how that kind of a problem turns into what? A second degree trinomial, right? Second degree term. Now what about the denominator? You take the x squared times 21 over x squared, what do you get? 21, isn't it? See, it's 21 over x squared times x squared. What happens? The x squareds go out, don't they? See, it's this one. This times that is the same as that one times that one, wasn't it? Okay. So this is kind of go backwards, right? According to what the other one. So what's this middle term? When I take this one times the minus 4 over x, what am I going to get? I'm going to get an x minus x, but what's going to be in front of the x? 4. And then when I take the x squared times 1, what do I get? X squared. Now, whenever you see a problem like this, you should expect some kind of result like this, right? When you have denominators that are, 1x, x squared, you should expect that you're going to get something that looks in this order, right? So in future problems, that's what I'm going to try to say is, when I'm looking at expectation, that's what I'm going to want to do, be thinking about. Now then, is that thing ready to be factored? The numerator is, but the denominator is not, is it? Because what should it be written as? Descending order, leading term positive, right? Well, if I write it in descending order, it's a minus x squared minus 4x plus 21. Is that right? Is that right? Now, in order to be factoring that thing, what do I got to do to it? you want to take a minus sign out of that thing, right? So that your leading term is positive. Otherwise, it's going to be really, really hard to factor. Now, if I take a minus sign out, where do we put the minus sign? Remember, we put it out in front, right there? And then we change the sign of each one of these. X squared plus 4x minus 21. Now we're ready to factor that thing, right? Let's look at that numerator. What do you think? I mean, you should roll through your head all those things. You know, it's a trinomial, leading term, positive, descending order, not a special case. So what is it you're going to try? Okay, that's right. So it'll be x and x with the signs of plus and minus, right? Because that's negative. So two numbers times itself is 18, whose difference is 3. Six and 3? Which is positive?
6.
The 6. Larger number has got to be positive. So now that one's factored. Now what about this denominator? Okay, it's the same deal, isn't it? X, and it's a plus and minus, right? Two numbers times itself is 21, whose difference is 4. And which one's positive? 7. Now we got the numerator factored, the denominator factored. What do we look for? Something to cancel, right? Common factors. What is it? Okay, it's x minus 3. So now my answer is going to be, what? What else do we have to have there? The minus sign, right? Don't forget that. And there it is. I want you to look at 9. That's the easy one, right? That's the easy one. Now that thing is going to change everything around, right? Tell me what that denominator is going to be. Just in your head, can you tell me? The 1, remember, the 1 is going to be what? X squared, right? And the constant, the one that has x squared in it, is just going to be a constant, right? So that denominator is going to be x squared minus 9, isn't it? Can you just see that? X squared. What are you going to factor x squared minus 9 into? X plus 3x minus 3. Tell me about that numerator. The squared term in the denominator is going to be the constant term. So you're going to have a 6 on the end, aren't you? And then where you have just the 1 in the front, that's going to be x squared. So the middle is going to be what? Minus x. So that's going to be two numbers times itself is 6, whose difference is 1. What is that? 3 and 2. Now do you see you're going to have a common factor? You're going to have that x minus 3 in the denominator and x minus 3 in the numerator, right? Can you see that? You'll see, I mean, that kind of should, you kind of should be getting a feel of that kind of a thing when you're working problems. Then you'd work the problem. Now, sometimes what you think happens won't happen. But that's the kind of the way you should start looking at problems, is look at them and see what you expect the answer to be. I want to look at 20. 20 says A plus 4 plus 5 over A minus 2. And then it's A plus 6 plus 15 over A minus 2. So what is the least common denominator? Okay, A minus 2. Now I want you to take a minute, look at the problem, and think about what it is that it's going to look like. That A minus 2, you're going to multiply it by the A, right? In the numerator. This times A minus 2. Then you're going to multiply the 4 times A minus 2. Then you're going to multiply this by the A minus 2. And when you do this one times A minus 2, you're just going to end up with a 5, right? These two are going to be distribution problems, aren't they? Is that right? This is what I'm telling you. I'm telling you, when you do this, it's going to be A times A minus 2 plus the numerator, 4 times A minus 2. Then when you take A minus 2 times this 5 over A minus 2, it's plus 5. Is that right? So is the denominator going to be the same kind of thing? It's going to be this A times what? A minus 2, isn't it? It's going to be this 6 times A minus 2. And then when I multiply this by that A minus 2, common factors are going to drop out and I'm going to have a 15, right? Is that right? So it's going to be the denominator, A times what? A minus 2 plus 6 times A minus 2. And then plus 15, right? Now what am I going to have to do next? Distribute, right? And I'm just going to do it above this one. So I'm going to distribute this A across this. A squared minus 2A. Then I'm going to go plus. Now, I can drop my brackets because it will not change the signs. I'm going to go 4A minus 8. And then it's plus 5. Now you tell me on the bottom, what's it going to be when I distribute? The first term on the bottom is going to be what? A squared 2A okay? Just exactly like that numerator, right? Now what do we have to do? Combine like terms and write it in descending order. So the numerator is A squared plus 2A minus 3. Is that right? The denominator, A squared plus 4a plus 3. Aaron, did I lose you?
No.
Okay.
So for how you got the 4A, it's because you would change the signs before, right? Like
This 4a right up here?
Yeah, no, down at the bottom.
Oh, this one.
Yeah.
I combined the
Because-
negative 2a and the positive 6a.
Okay, that's what I thought.
Yeah. Glad, when you don't understand, ask. Now what I'm going to do is I'm going to write my result because it's kind of a long ways away. I got a squared plus 2a minus 3 over a squared plus 4a plus 3. Now what do we have to do? Try and factor the numerator and factor the denominator, right? So it's ready to be factored by trial and error. That's the only way we can do it, right? So that's a binomial sum of pairs over the integers. And it's a and a with a what signs? Plus and minus, right? So that's what two number multiplied gives you 3 whose difference is 2. 3 and 1. Which one's positive? The 3 is positive and the 1's negative. Now this one, it's not a special case, so it's trial and error over the integers. A and a with the signs of what? Both positive. Because this says same sign, that says plus sign. So now what two numbers times itself is 3, whose sum is 4. 3 and 1. So it's 3 and 1. Now you look for common factors down here and up here. What do you got? A plus 3, right? You got that a plus 3 and this a plus 3. So what is left? A minus 1 in the numerator and an a plus 1 in the denominator. Good? Okay, I'm going to do 28. Says 3 over n plus 1 plus 1 over n 2 over n plus 1 plus 3 over n. What is the least common denominator of all denominators? N. Is there something else? And n plus 1, isn't there? So you have to have that one, and you got to have that one. So now it's now notice you're going to multiply this thing in the numerator times each one of these terms. When I multiply this one times this one, what goes out? What's common? The n plus 1, isn't it? That goes out, and so what you have left is you have 3n. Does that make, do you want me to do it out? You see that? When you take this number times this one, what goes out? The n goes out, right? The n's. And you have what? An n plus 1. Now you could put it in the brackets or not. because it's not going to change signs no matter what. When you take this one times this one, what goes out? The n plus 1s, right? So you have 2n. When you take this one times this, the n's go out, and you have plus 3 times n plus 1. You follow it? Do you have any questions on that? Now what we have to do is we got to distribute this thing. Now that numerator, notice that what it is. This is 3n. That plus does not change the sign, so you could actually just go ahead and combine it. 3n plus n is 4n plus 1. Right? Now this one, denominator, you have a 2n plus, you got to distribute the 3n plus 3. Now combine like terms, and what do you have? 5n plus 3. Now what's my answer? I'm going to write it over in the right. What's the numerator? 4n plus 1. What's the denominator? Now, do you have any questions on that?